In this second lesson on transformations of graphs of functions, I will talk about vertical and horizontal scalings. We start with vertical scalings, an example, and the familiar graph of f of x equals x squared. From f of x equals x squared, let's see if we can graph g of x equals 3x squared. Okay, well, what's happening here? G of x equals 3x squared takes f of x equals x squared and vertically stretches the graph of x squared. What about h of x equals 1/4 x squared? This graph takes the graph of f of x equals x squared and compresses that graph vertically. How do we graph vertical scalings? Suppose f is a function and a is greater than 0. To graph y equals a times f of x, multiply all of the y coordinates of the points on the graph of f by a. So we're going to multiply the y coordinates by a. If a is greater than 1, the graph is vertically stretched. If 0 is less than a is less than 1, the graph is vertically compressed, as when we had a equals 1/4 in the previous example. Use the given graph of y equals f of x to graph y equals 2 times f of x. So what are we doing here? We're taking each y coordinate on our graph and multiplying it by 2. Our first point on this graph is -4, -1. We take the -1, multiply it by 2. That gives us the point on our new graph of -4, -2. We next look at the point on the graph that we're given here of -2, 1. We take the y coordinate of -1, multiply it by 2 to give us the point on our new graph of -2, 2. And I'll connect those dots as we go along. The next point on our graph that I'm going to work with is 0, -2. Multiplying the y coordinate of -2 by 2 gives me the point 0, -4 on our graph. And last of all, the point 2, -2 on the original graph, multiplying the y coordinate by 2 gives me the new point 2, -4. And so this red graph is the graph of y equals 2 times f of x. What about horizontal scalings? Here's an example. Sketch the graphs of f of x equals x squared and g of x equals 3x squared, the 3x being in parentheses. Let's see what happens. Okay, well, it looks skinnier, and what we say here is that we say the graph is horizontally compressed, so it's smashed in horizontally, if you think of it that way. What about the graph of h of x equals 1/4 x squared? This graph is what we call stretched horizontally. How do we graph horizontal scalings? Well, suppose f is a function and b is greater than 0. To graph y equals f of bx, we divide all of the x coordinates of the points on the graph by b. If b is greater than 1, the graph is horizontally compressed. If 0 is less than b is less than 1, the graph is horizontally stretched. Let's take our given graph of y equals f of x and graph y equals f of 2x. Okay, so this is a little bit trickier. We're going to look at each point on the graph, starting with -4, -1, and we're going to divide by 2 here, our x coordinate. So we'd instead of -4, -1, we would have -2, -1. Okay, here we have the point -2, 1. Our x coordinate, if we multiply that by 1/2, would give me the point -1, 1. And we move on to the point 0, -2. Multiplying 0 by 1/2 is still 0, so we have the same point. We move on to the point 2, -2. Multiplying the x coordinate 2 by 1/2 would give me the point 1, negative 2. And I'll connect the dots here. And you can see our original graph is what we would say horizontally compressed. Okay, try this last one on your own. Use the given graph of y equals f of x to graph y equals 1/2 f of x.